In this video we are learning about linear relationships, and to be successful in this work you need to be able to do some things that involve linear relationships. They're to do with graphs and also equations. So we've got a situation where we've got petrol, okay, and petrol, you might have seen the signs at service stations or on petrol pumps, and let's say we've got petrol at $1.50 per litre. So if we got petrol at $1.50 per litre, let's have a look. If we bought no fuel, we would pay nothing. Okay, so let's say in the left hand column here we've got the number of litres. So you can see I've got 0 litres, 1, 2, 3, then I've got some bigger amounts, 10, 20, 30 and 70 litres, maybe a full tank on a bigger car, and this would be the cost. So we buy 0 litres, it doesn't cost us any money. Well, it's pretty obvious. So if it's $1.50 per litre, that would mean that if we buy 1 litre we pay $1.50. If we buy 2 litres, we've got $1.50 times 2. So $1.50 times 2 would be 3 litres. So we can enter these amounts in. Okay, you can see while I did those, they would create these dots here if you were watching the video. So the other thing we know is that the dots seem to all be in a straight line. If we look at going up here, follow the cursor up, looks like it's in a straight line. In fact, if we plot an equation that you can see down here, C equals 1.5 times L, what do you notice? That all the dots are sitting on that orange straight line. And that's an example of a linear relationship. If all the dots or all the points fit on a straight line, on the same straight line, we have what's called a linear relationship or a linear function. And linear means straight line. So you can hear lin in line, okay, and there's no accident. Notice how this one went through 0, 0. Let's look at another one. Now this one actually happened to me about 4 years ago when our previous washing machine died, and we got some fix-it guy to come in and see if he could fix it. He couldn't, because it's made of cheap parts and it wasn't worth fixing. It was going to cost more than what the machine was worth, but it still cost us money to get him to come out. So he came straight out and he found the issue straight away, and that cost us $200. So can you see highlighted this $200? And that means he spent no hours doing a job. Straight away he could see with just minimal time that, yep, nah, it's no good, and that cost us $200. And then we had to buy a new machine on top of that. So that's called the call-out fee. That's an example of when a graph doesn't go through 0, 0. This one goes through 0, 200. So it cuts the vertical axis or the y-axis at 200. You might remember just a minute ago we saw 0, 0. So some of them cut through at 0, 0, and this one cuts through at higher up than that, 0, 200. That means 200 on the vertical axis. So we can work this out pretty easy. If we have this equation here, it actually works out, you know, what the cost would be for such a technician to come out and fix such an appliance. So if we do it manually first, we can see it happening. So if the call out fee was $200 and there was no work done, number of hours spent, H, would be 0. So we would have 200 plus 40.5 times 0, which is just 200. Now, what does the 40.5 mean? Well, that was his hourly rate, $40.50 an hour. Okay, and that's called the hourly rate. So that gets added on to the call-out fee, which is a constant. It's 200. So the 200 stays the same, but what changes is the number of hours that go by. If it's a small job, it might only take 1 hour. If it's a bigger job, it might take 3 hours, and so on, or parts of hours. So if it takes 1 hour, we've got a little thing we can do here. So the sum we use is when h is 1, we have 200 plus 40.5 times 1, which is 240.5, and you can see the result there. Okay, and so for h equals 2, that would be actually changed to a 2 there, and that would be changed to a 2, and we would have 200 plus, alright, so that would be 81, 40.5 times 2, and we have $281, and we can enter those in like so. And I've just entered the others in, and you can see that the dots get added on there and they form a straight line. And this is another linear equation. So when we're going along, we can see that it all forms a straight line, linear equation. So what we notice is something. We notice that for a certain movement this way, or certain distance that way, we go up a certain distance. And that keeps repeating. Certain distance that way, we go up a certain distance. And repeat that the same again. Certain distance that way and another distance that way. That keeps going, and that's a bit like stairs, and it creates that straight line. So that's a linear equation. Or in other words, a linear relationship. So just remember, when we've got this, we've got for a certain distance that way and some other distance that way. If we keep repeating those two distances, the same across and the same up, you'll get a linear relationship. Sometimes they go through 0, 0, sometimes they don't. Some very important things, you probably should have learnt this previously, but just in case you've forgotten or it slipped past you somehow, we need to look at some very important things here. So this area of maths is called coordinate geometry, and it's important because it links geometry and algebra. Now, very important, this is called a Cartesian plane, the X and Y axis system here, alright, which you've definitely seen before. The proper name is a Cartesian plane. When you were little, you only learnt positive values of X and Y, and you only looked at this first quadrant. But since then, you know that there's also negative numbers each way. It's really just two number lines put together. It's a horizontal number line when you've got 0 in the middle, and you've got negatives there, positives there. Sorry, that's a positive one. Combined with a vertical number line, those four sections are called quadrants, and the horizontal axis is often called the x-axis. The vertical axis is called the y, and it intersects at the origin, which is coordinate 0, 0. The axes are at right angles. A point is precisely positioned on the Cartesian plane. That's called an ordered pair, or sometimes it's called a coordinate pair. Look, x comes before y in the alphabet, and x comes before y with our numbers. You can see a bunch of examples there. We've got 3, 1 is because we go 3 in the x direction, 1, 2, 3. In other words, horizontally to the right in the positive x direction, and we go 1 upwards in the positive y direction, so hence 3, 1. Whereas we got 1s, so down here in the fourth quadrant, we go, if we look at that one there, which is 2, negative 4, we've got to go positive 2, but we go 1, 2, 3, 4 down this time, that's negative 4. So, and if we look at one last one, negative 2, negative 3, 1, 2 to the left, and 1, 2, 3 down to the right. Okay, it's a whole lot of points which make a straight line. We can get a rule from that. The x-intercept is very important. It's the x-coordinate where the graph cuts the x-axis. The y-intercept is the y-coordinate where the graph cuts the y-axis. So this example here, that point there is called 2, 0, and 2, 0 would be the x-intercept of that line. The y-intercept is at 0, 4, 0 to the right and 4 up, and that's where the graph cuts the y-axis. The other way of telling is that the x-intercept happens when y equals 0. See that there? That is very important. So the x-intercept happens when y equals 0. Always, always important. The y-intercept happens when x equals 0. Those two facts are very, very helpful. Okay, as a quick example, if we restrict x to be from -3 up to +3, and that's how we write it, construct a table of values and plot a graph, and given this rule or this linear equation. So we've got y equals -2x plus 2. What do you use for x? Because you've got to start with x. Well, it says keep them between -3 and 3. So that's your lower limit, and that's your upper limit for x. And it's logical just to use simple whole number values in between. And if we put these into the rule, that would mean that for wherever we see an x, for the first one we'll put in or substitute -3. So we have -2 times -3 is +6. +6 plus 2 is 8. And we do the same with all the other numbers. And we get ordered pairs, so that point there. Lastly, a final example. Write down the X-intercept and the Y-intercept for two things. Firstly, this table, and secondly, we'll do it for a graph. Now, remember, the X-intercept happens when y equals 0. Okay, scan, where's y equals 0? Y equals 0. So the X-intercept will be at 1, 0, because we write x before y. The Y-intercept happens when x equals 0. So that we scan the table there. When does x equal 0? There. So it'll be the point 0, 2. So 0, 2 will be the Y-intercept. On a graph, we've got to look at the point where it cuts. That cuts the x-axis there. That point is called -4, 0. So that's the X-intercept. The Y-intercept is there, and that point is called 0, 6.